This time, I would like to go through more formal steps of hypothesis testings. First step is state the null and alternative hypothesis, and the second step is set an alpha level and define the critical region. And the 3, collect sample data and compute the necessary sample statistics. And 4, calculate the p-value. And 5, compare the p-value to the alpha level. And finally, reject or fail to reject the null hypothesis. This is exactly what I did previously in my previous video, but this time I'm gonna just specifically follow these steps, especially thinking about each step. First step is stating the null hypothesis and alternative hypothesis. In the previous example, the null hypothesis would be there's no effect. H0 indicates that this is null hypothesis. HO. So the null hypothesis is always something like there is no effect or no relationship or no difference or no anything. No anything that we're trying to prove, to find. So this indicates that there's no change, there's no positive effect. There is no positive effect, that's what it is. Because, it's smaller than or equal to 100, so there's no change. Alternatively, we could have said, well, actually, it's a directional test. We know, or we assume that there'll be a positive change, so that's why, otherwise, if it's going to be a negative or positive, we don't know if it's negative or positive, then we would say, it remains the same. In that case, null hypothesis would be mu met is equal to 100. But in this case, we know that it's going to be positive effect. So null hypothesis would be there's no positive effect. So indicating there's no positive effect, this is the notation we use. So it's going to be equal or negative, So that's okay. That's what it is. The alternative hypothesis in our example is that the medicine, notice this is not denoted by 1 instead of H0. You write it H1. And the alternative is that medicine does have a positive effect on the population mean. So mu med is greater than 100. That's how you write. I kind of bubbled about this in my previous video, but if I use the follow the steps, and use notation, it's like null hypothesis is mu med is equal to or smaller than 100, and the alternative hypothesis is mu med is greater than 100. Again, in alternative hypothesis as well, we are indicating that it's going to be possibly be greater than 100, indicating greater clearly or smaller clearly. It's indicating directions, positive or negative directions, and we call that directional alternative hypothesis. It's directional. So step 1, state the hypothesis. To simply put, we can just write these two. Null hypothesis mu med is equal to or smaller than 100, and alternative hypothesis mu med is greater than 100. Later on in non-directional hypothesis testing, we are going to have different notations, but here, because it's directional, this is what's going to be. And set alpha level and define critical region. The alpha level is, for educational and social science research, it is 0.05, so we use alpha level with 0.05. And critical region. If we know whether or not our alternative hypothesis has direction, we can define the critical region or standard normal Z distribution, we know that our alternative hypothesis has a positive direction, and because our alternative hypothesis has a positive direction, our critical region is going to be on the positive side of our standard normal distribution. What it means is that, okay, so this is a z point, and this is a z score for alpha level 0.05. So the critical region is here. If the sample statistic falls into this region, then it's probably a rare case. It's outside the range of just sample variability, sample error, so sampling error. So this is definitely not. This is definitely some effect. When we can conclude that some statistically significant effect has been observed. So, and we reject the notion hypothesis that there was no effect, because there was some effect, statistically significant effect. And z-score here is somewhere between 1.64 and 1.65. That's why it's roughly saying 1.65. We can say set the z score 1.65, and we can, if z score is greater than that 1.65, we can clearly say that it's within the 5% region. We don't want to say 1.64, because if it's 1.641, it's probably, my guess, it's outside the 5% region. And 1.65 is a little bit too, little bit into 5% region, so it's probably like a 4 point some percent, 9 some percent, but it's safe to say it's to use this number rather than 1.64 something. So let's collect some data. And the data we collected was, sample mean was 105, so that's what it was. And also, from this assumption or hypothesis, null hypothesis, there's no change in sigma med 15, and from that we gather this idea, normal distribution, and the mean 100, and this is the standard deviation of a sample, which is 1.5, was it? Yeah. And the z-score for that was 3.33. It's the same as before. So that's the step 3. And for step 4, calculate the p-value for that. And p-value was, 0.0004, and it's that, 3.33, and the p-value was that. So that's step 4. And step 5, compare the p-value to alpha, and alpha was 0.05. And my p-value is 0.0004, and my p-value is less than my alpha level. And finally, step 6, make a decision about null hypothesis. Okay, so if the p-value is less than alpha level, reject null hypothesis. Why do I reject? Because if it falls into its majority, then we conclude that the result, the sample mean we found was, if it falls into this region, it's within typical value that we will pick from the population of mean 100. But if we go outside this, what it means is that those are rare cases, and the cases that you won't see from the sample population. Population of with the mean of 100 and standard deviation of 15. So this is if it falls into this region, would reject that the population was, it's the same thing. We're just going through the steps, official formal steps, Okay, so finally, what you do is, okay, because my p value is lower than my alpha level, I reject the null hypothesis. Observing a sample mean as high as 105 is so unlikely. If there's no effect, then I decided to reject my the null hypothesis of no effect. The probability is less than 0.05. Probability of you getting 105 from that population is below 0.05. So my sample data are inconsistent with my null hypothesis. And make a decision about null. I reject the idea that the medicine has no positive effect on IQ in the population. I conclude that the medicine does have a positive effect in the population. I could have come to the same conclusion by observing the z-score for my sample mean, z equals 3.33 was greater than the critical value of z equals 1.65. This would automatically tell me that my p-value is not some 0.05. That's another way. If you can visualize this, you wouldn't really have to calculate the p-value for this, 0.0004, because you can automatically tell z is here and z is here, z for the sample is here, and critical value, z score of critical value is here. We make four main assumptions when we do a z-test like one we just did. If one or more of these assumptions is violated, our results may be inaccurate. Okay, the sample is representative of the population of interest. Taking a random sample of participants helps ensure that the sample is representative. Observations in the sample are independent of one another. If in our example we assume that each person's IQ score is independent of every other person's IQ score in the sample, taking a random sampling helps ensure this independence. The population standard deviation is unchanged by the treatment. We assume treatment effects would change the population mean, but not the standard deviation. That I don't really understand. Normal sampling distribution I am. Otherwise, we can get our p-value from the standard normal table. But we know how to evaluate whether it's normal or not.